Hello everyone, my name is Subhasis. In part 1, uh, we have covered how to get information from DataBricks workspace about set of clusters which are available in a DataBricks workspace, and then what all jobs are running or what all jobs are scheduled in that particular workspace. In today's session, in part 2, we are going to capture those information what we already captured in the previous chapter, previous session, and we are going to push them into MySQL database tables. We'll create the schema, we'll create set of tables, and we'll push the cluster jobs, all those information, and we'll try to correlate those information. And in the final part of the video, we will show you different kind of visualizations, dashboards in Apache Superset. Okay, that's the objective for today's video. Let me share my screen. So this is the folder DataBricks under Cloud Infra Cost. In first video, we have covered chapter 1. Today, we'll be covering chapter 2. Let's follow the README for a glance to see the objectives and how we're going to achieve them. First part of the objective is we know how to find out in a DataBricks workspace details about clusters, jobs, scheduled, and then correlating information between cluster and jobs. Today, we are going to primarily cover how we push the information into database, MySQL tables, and then visualize the data. Prerequisite, obviously, we'll have to install MySQL, Apache Superset. If it is already, both of them are installed, then you can skip that part. Otherwise, you can follow the steps which are in the official documentation of for MySQL installation and Superset installation. Okay. In my case, I have installed MySQL locally in my local host, and then for Apache Superset, I have installed using the Docker Compose file. So let me actually running through quickly for both of them. Yeah. So you can, I'm using Mac, so based on your operating system, you can use the installer. I have used the DMG file and then installed it like this. Okay. You can follow the exact same steps. The other one, Apache Superset, I have cloned the GitHub repository, exactly the steps they have mentioned here. And then I have used Docker Compose command here. All right. So that is about the prerequisites. In the steps, first we'll create the required set of tables. So if you clone this repository and go to chapter 2 code, you will see I've created set of new files here, tables.py. Let me open this in Python. Now, so primarily we'll be creating 3 tables. One is database clusters. Second one is DataBricks jobs, and the third one will be DataBricks cluster jobs, the association table. In the cluster table, we have captured as much as information that we can get from DataBricks API about the database cluster, like a cluster ID, cluster name, source, between UI or job, right? Those are the different kind of cluster sources that you can have in DataBricks. And then few other things like auto termination minutes and all. Few important things are min workers, max workers, and then what is the state of the cluster, right? What is the node type ID, driver node type ID, basically the VMs queue types. The second table, which is DataBricks jobs, this is for capturing the job related information, scheduled job information like job ID, job name. If it is associated to an existing cluster ID, in that case, although I'll tell you, like, even if you skip this, it's not going to cause any trouble. However, you can capture the cluster ID. I'll tell you why this might not be required to be part of the jobs table. Okay. And then important things like you get the quartz cron expression Again, it might be a little cryptic. So what I've done is I've created some utility which will convert them to like which day of week, which hour of the day, which minute of hour. So let's say you have scheduled a job that runs every Tuesday. So you'll have day of week as Tuesday. Let's say it is scheduled at 9:30, ninth hour. So it will have 9, and then this minute of hour will have 30. Yeah. The third table is the association table. And for that matter, you can see the primary key constant, it's the composite key, cluster ID and job ID, and they reference to the cluster ID is referencing from DataBricks clusters cluster ID column, and the job ID is referencing. There is a foreign key relationship that I have defined. Okay. Simple 3 tables. Let's go back to the set of steps. Once you have created the tables, right, then you can run the database clusters py for capturing the cluster information and pushing to the cluster table. You can run database jobs py, which will capture the scheduled job information from database and push to database jobs table. And the third one would push the combined data, right? The database cluster to jobs association information into the third table, cluster jobs table. Okay, let's run the steps one by one. In my case, I'll just show you. So I don't have any schema for this particular use case right now. I have the script handy here. I'll show that. So for creating the schema, I have kept now because I have run this earlier also. So the user is already created. I'm not going to run the user creation part, but because you'll be running first time, make sure you uncomment this and you run it in your MySQL database. Okay. So what the first line is doing is creating a database cloud infra DB. And then the second step is creating a user, cloud infra user, password, cloud infra pass. You can give any user password of your choice. And then you say grant all privilege on cloud infra DB dot start to this user. Let me run this. And if I refresh here, okay, you have an error in your SQL syntax. What is the error? Check the manual. Let me run it again. Okay, there you go. Probably I selected partial text when I was executing earlier. Not to worry. You can see the schema is created, the database is created. However, tables, views, or nothing is there right now. That's where I'll go to the next step. I should have mentioned that in the step, but just for now, you can run this tables.py. Okay, this does not require any other environment variable or anything, just run this as is. One thing that I want to call out is for connecting to the MySQL server here, I've created one singleton class. If you go there, because you may have your choice of database, right? In that case, I would suggest you can create one more class for connecting to your specific database type. In my case, it is MySQL. So if you're using MySQL, well and good, you can use this as is, and the the database user and password we just created, right? So I'm going to create a session by connecting to that MySQL database. Here I'm going to do this MySQL session, and I'll get few objects from that session, base and engine. I'm using SQL Alchemy for creation of my tables, right? And it requires those constructs. So once you define these classes, you say base.metadata.create all engine. Okay? So it will create all these 3 tables in the target MySQL database. Let me run this. Now you can go and check in your SQL server. If you refresh this, you will see 3 tables are created, and like you defined the table definition, You can see all those columns would be created. Cluster ID, cluster name for clusters. For jobs, you will have job related column, and then the association table will have cluster ID and job ID. Okay, we set. Before I do the next thing, I'm going to obfuscate some of this information so that the actual cluster name or actual job details can be obfuscated. Okay, I have enabled the obfuscation in my environment. If you have to obfuscate, you can go and edit this file obfuscate underscore .py, and whatever text that you want to obfuscate, please put them in that file and run the rest of the scripts. All right, so we have done till here, and then we have created the tables also. Now the next part is, in order to be able to connect to the DataBricks workspace, you'll have to set these two environment variables. Okay, I think I missed this part to show you in the previous video as well. But go and connect to your DataBricks workspace, the UI, and get these two information: DataBricks host and token. And then you open the terminal and set those two variables. Okay? You can say like it is set here: export DataBricks host equals to the actual value of your DataBricks host, and likewise for the token. Okay, please do that in the terminal, and then go to the next step, which is Python database clusters.py. I'll show the implementation before I run this. So if you go to the clusters py, what you see, the exactly same code that I showed earlier. However, at this time, I have added the MySQL connection, and then I'm going to construct the object for each of the clusters, so that it's basically I'm filling in the bin details, right? Once I fill in the bin details from the cluster information that I've got, I'm going to add that to session. And finally, once I've added all those objects, all those cluster objects, I'm going to run one single commit command, right? So I'm batching the entire set of clusters to be created at once in the database. And in fact, if you go to the jobs also, you'll find similar implementation. Okay, there is one additional function that I have implemented for parsing the cron expression and then extracting those three details like scheduled day of week, hour of day, and scheduled minute of hour. Apart from that, the existing old code itself, here also I'm creating the job object, and then I'm committing them for once. Okay. Nothing fancy. And then the third file, which is going to create that correlation between the cluster and jobs. Again, the implementation remains almost the same. I'm getting all the jobs list, putting them into different set of dictionaries for looking up later. And then I'm getting all the clusters details, navigating through each of the cluster, and then figuring out for each of those cluster, what are the jobs which are running, and creating that association here. Finally, again, I'm creating that cluster job object in each of those if-else section. And once that is done, I'm doing commit for once. Okay. So let's run these three scripts one by one. First, let me create the clusters in the database. Okay, if you go into the DB table now, so we populated the clusters table, and you can see all those clusters information have come. These are obfuscated, obviously. I cannot show you the actual cluster details here. Likewise, we'll run the two other scripts, which is DataBricks jobs. and the final association script E2E. There you go. So the second part of the objective has been met. We have been able to push the information into those three tables. You can come and run, and you can see the jobs table also have been populated. And then the final association table also, you can see that also has been populated. Okay, that's the second part of the objective. And the third part is the superset, right? So once you have installed Superset, and you can go to your Docker dashboard, and you can see Superset services are up and running. If you go to Superset app, which is the web application of it, and you can go to the log of it and figure out in which port it is running. So in this case, it is running in http:// within that Docker container :8088, and the port is mapped to localhost. So if you say localhost :8088, I think I have already opened it. Yeah. So if you if you just open the host :8088, you'll be able to see the home page of it. First time it will ask you to log in, right? And then the user password that you will use for first time is admin. Okay. The any other users you might create, it might not have all the privileges. So it's suggested that you will use the admin user to log in. Once you log in, you can see all those details here. Not sure. Yeah, it took a little while. Sorry about that. But the first thing that I'm going to do is, create a database. Okay. And for now, I have already created, but I'll show you how you create that. So connect to database, and then select a database to connect. You can say MySQL. And then we put the host name. Now, in this case, this is important. So because the service is running inside a container, should not use localhost, but you should use host.docker.internal. Okay. And the port is, I'm assuming it is 3306, not 3000. And then data_infra_db. Username, cloud infra user as user, and cloud infra pass as password. Provide that information. Display name, you can say, I already created, as you see, cloud infra db. I can create as -2 so that it is separated from the previous one. And finish. So the database is created. You can go and run some SQL queries. So for that, you have to go to SQL editor. Okay, and then the database I'm going to choose. I'm going to create a new query window here. Okay, let it populate. It's taking a while. Okay. Select this dropdown and select MySQL Cloud Infra DB2. And the database is Cloud Infra, the schema is Cloud Infra DB. Okay. And this is optional. So you can now start running your queries, right? So you can just say select star from DataBricks _clusters, let's say. Click on run. See, it is getting all those column information. It's running the query. Somehow it is a bit slow today. In the meantime, I'll show you. I have created a slightly complicated query, slightly complicated. So select C.star, which is clusters. I'm getting all the columns. Then from the job table, which is DataBricks jobs J, I'm getting few selective columns like job name, created time, pause status. I used an alias here because the cluster also has the same column name, created time. Just to differentiate between these two columns, I have said J dot created time, which is the job created time alias, and then J dot pause status, where the job is paused or unpaused. J dot quads cron expression and few other related columns here. And then the joins, if you see, and that's why I said in the jobs table, database underscore jobs table, the existing cluster ID, that column is obsolete. That is not required because if you see the joins here between cluster table to the job table, there is no direct relationship, right? So cluster to cluster jobs. So this intermediate table is joining between both clusters and the jobs table, right? All right. So if I run this, which is the exact replica of it. All right. So you can see the clusters table I could run and get the output. For now, I'll just copy this query to save some time. Otherwise, I can type that whole thing. It's not a complicated one. And I'll just run it. Okay. So I'm getting the data from all three tables that I'm interested in right now. Again, I've obfuscated that information. So in your actual cluster, the cluster name would be slightly different. But here you can see those are obfuscated. User information and the job name, everything is obfuscated. So these are not really actual job names, right? So here it's like I've used a series job 1 to some number. And then these are some of the information that I've parsed out of this cron expression. So this schedule cron expression is actually Monday, 8 o'clock in the morning. Okay. I excluded the second part because that's not of interest for building my dashboards. Okay, so very quickly now I'm going to, the next step is you have to click on explore. You can actually save your query as well. So you can say cloud infra DB, right? Cloud infra DB, sorry, query. I'll say 2 because I've created a separate instance. So let's use that. The next part is you have to click on explore, which is actually taking you to the next level because you want to create a new data set. In this case, I will say cluster job dataset 2. Okay, it's not actually override. So I'll say save as new. I'm creating a new data set. This is the next step. So you first connect to the database, create a SQL query, you save it, and then go to the dataset creation in Superset. All right. So when you are in datasets, you can start creating your charts. Okay. Now what I'm going to do is I'm going to create a new chart, right? So I'm already in that page. It's trying to run that query from the data sets and I can select different chart types. So let it bring it up. Actually, I'm going to use the chart type as table, first one. Okay. So you can see different kind of chart types which are available to you. For now, I'm going to use the simple table and then I'll go to the advanced ones, pivot table. Okay. So first simple table, and in that I'm going to display the data as is. I'm going to give it a name. I'll say cluster jobs. Save it. And then you can add to a dashboard. Okay. Now I will give it a different name, database cluster jobs, and I'll say 2 so that I understand this is from this particular uh, video that I'm doing. I'm going to say, add to dashboard later. I'll show that separately. So I have one chart which is created out of that data set. And next thing that I'm going to do, I'm going to actually create a dashboard and add this chart to that dashboard. So let it do whatever it is doing. I'm going to go to the dashboard page now. The browser is in hung state. Let me go from here. Okay. Okay, so I'm going to create a new dashboard for this video, fresh one. Some of the connection between the Apache Superset, which is running in the container, and the MySQL connection. MySQL is running in my host system. Somewhere it is a bit slow. I have not seen it so slow earlier. Anyways, I'll give it a name. I'll say DataBricks dashboard. Let's say 2. And then I'm going to add a chart to this, right? Click on this chart tab here. And then you can get all your previously created charts. Just drag and drop. This part is pretty convenient, so you can just increase its size as well. And you are set. Just save it. There you go. Your first dashboard is ready. And you can also maximize this. Now, in this case, you don't get much benefit other than the vertical part. Right? You get to see more number of rows if you see in the maximized state. Okay, so you have all those, cluster ID, you have got the cluster name, and then you have all other details, including the jobs and all. Let's create the second chart. This one will be interesting. Did I not save the dashboard? Click on the chart. One more chart I'm going to okay, I published the dashboard. I can add to my favorite as well. And then I'm going to add one more chart. This time I'm going to add a pivot chart. Dataset will be cluster job dataset 2, and then pivot table, create new. If I go to the dashboards list, sorry, I'm switching in between. I should be able to see my new dashboard now. DataBricks dashboard 2. Let it refresh. We'll go back to my chart creation page. Okay. Let's see. So the rows that I want is cluster name. No, before even that, right? I want to have scheduled day of week. So on which day, hour of day, minute of hour, and then I'll add the cluster name. So basically, on this day of week, on this hour of day, on this minute of hour, in which cluster, so it's cluster name, and then what all jobs are running. So that's about my rows, and the metrics. You want to show count of jobs. Okay. So I'm going to just say job name, and then or I can say pause status. Also, I can do pause status. Pause status. Let's do pause status, and then say count. Okay. Save it. So I can run the query now, but I'll add one more thing here. Okay. In the columns, I'll add something, and I might have to filter out some data like the nulls. There are a few nulls that I'll filter out. So count of pause status is 1. I'll add pause status so I can see the count of, jobs which are paused, count of jobs which are unpaused, right? That will be a better view of the data. Yeah, you can see paused and unpaused. And the next thing is I'm going to filter out the nulls from both here and here, right? Let me filter one by one. So I'm going to filter first scheduled day of week as null. Not equals null. Okay. Let's see the data. Okay, Monday. Yeah, this is basically it's not scheduled, right? That's where you'll find for some clusters there are jobs, but those are not scheduled. So that's what you'll see not applicable. I can filter that as well. Okay. And add one more, and I can say the same thing. Actually, let me filter out the job names equals, not equals null. Every day, Monday. Yep. Pretty close. And then I'll remove this one as well. So, scheduled day of week. Not equals NA. Okay. My chart is now pretty clean. I'm going to give it a name. I'll say jobs calendar. It's a calendar view. Chart name is jobs calendar. I'm going to add it to my dashboard, right? Because the dashboard now exists. So I'm just going to add that. And if I go to my dashboard now, you will see two charts. You can see the previous chart that we added, and then the second one is jobs calendar. I'm going to edit this and then drag it till here. I'll add one more small visual chart on this side. So what this view shows you is, actually let me increase the number of rows. So that I don't have, sorry. I can see more number of rows without scrolling. Let's see if I have achieved that. Yes, you can see. Okay, I still have to scroll a little bit, but that's still okay. So this job is running every day, 9th hour in the morning. Cluster name is UA cluster 2, job name is job underscore 19, and it's in pause status. Monday, 2:30 a.m. under UA cluster 12, we have job 9 running, and 245 under UI cluster 6, you have job 6 running, and both of them are unpaused. That means they will get triggered in their scheduled time. One interesting thing would be, for that same cluster at the same time, if you have multiple jobs running, this is something from cost optimization perspective. This will be important thing to add, take care of or to adjust the schedule, because in the same cluster you are going to put so much of pressure coming from multiple jobs because they are scheduled at the same time. In this case, it is not a concern because 15 and 17 they are paused. Only job that is going to run is job 14. However, if all of them are unpaused, then that is something that you should be concerned about. Okay. Otherwise, you can just follow this Tuesday at this hour, what will jobs are running in which cluster. I'm going to add one more small, that would be probably the last chart that I want to put today. Can say plus chart. I want to create a new chart, and that would show paused versus unpaused count set. This time I'll add a donut chart. So I'll say pie chart, and the data set I'm going to choose is cluster jobs data set 2. Okay, and pie chart, I'm going to add metric as count of pause status and job name. And then group by, I would say pause status. Okay, run this. I'm going to filter out the null ones. So just add a filter, and that null is the job name or the pause status. Maybe pause status is not null. Okay, 6:40, and then I'm going to customize this a little bit. So I will say it's a donut that I want. Okay, and then I can reduce or increase the outer radius. This is good enough. I can also choose a different color scheme if I want. Let's pick something a little sober. Yeah. Okay. And give it a name. I would say paused, unpaused. Yes, I'm going to add this to the dashboard, and then I'm going to directly go to the dashboard as well. That's the last dashboard. That's the last chart that I wanted to create today. And let's see the placement. By default, it will place vertically. Editing and then drag it to here. This will be fine. In fact, if I had one more small one, then I could have added at the bottom to leverage the real estate here. Let's see how does it look now. There you go. Okay, I can make use of this room over here. It should be fine now. Still better. So if you see, okay, let me modify this chart a little bit, right? Otherwise, what will happen is I'll have to count, right? How many are paused, how many are unpaused. So 1, 2, 3, 4, 5, 6, and that's what you can see. We have total paused job count as 6, and this one is 14. If you count, it will match up. But there is a better way to visualize that data in a pivot chart, right? So let me go to the pivot chart and customize it a little bit. Jobs calendar, right? To a jobs calendar. I'm going to show the total of it at the bottom of that pivot chart. Okay. So I'm going to customize it, and then or was it here? Let's see. Yeah, it was here. So columns total, right? Let it load. There you go. Yeah, this is what I wanted to show, the sum of it. Yes, precise. All right. Yes. Save it. The chart is updated. Same chart. Now, if you refresh, you'll see slightly different view of the jobs calendar. Collapse this part. As it brings up the chart. Yeah, okay, there you go. So I don't need all the subtotals in individual rows. What I need rather is at the bottom, right? The good thing is I can collapse all of it, and I can show you the this 6 and this 14, right? Okay, so that's what I wanted to show in today's video, right? So visualize the data in Apache Superset dashboard. That is done. In the next video, I'm going to cover the cost aspect, right? So uh, because if you go to either Azure portal, to see the cost of the DataBricks individual clusters, you'll not see them, right? You'll get to see at the high level, at the workspace level. But if you want to see which cluster is costing you much, or which jobs are costing you much more than the other ones, to create that kind of a view, um, I am going to experiment from the run history of the jobs and the events from each of those clusters. By those events and the run history, I'm going to do some back calculation. Like if the cluster was running with so many number of nodes from this time to another time, how many nodes were running, what were the skew types for that, and based on what Azure charges or Databricks charges for those skew types, for per hour billing or per minute billing, I'm going to do that back calculation, right? So that way I'll be able to do the calculation, cost calculation at a cluster level. And same way, if the job has run, let's say 100 times, each of the time it runs for, let's say 10 minutes, right? And which cluster it is associated with, right? And in that 10 minutes, what is the average cost of the cluster, right? From these two information, I'm going to show you cost for each of the jobs for all of its historical run. You can see per run how much it costs in average, and for the overall count of runs for that particular job, how much it has costed so far, right? Cluster level cost and job level cost. That's what I'm going to cover in the next video. Thanks for watching.